Hi, welcome to this tutorial on the normal distribution. Now in this tutorial what I want to show you is how to work out the probability of being less than an observed value x, where x is greater than the mean mu. And in order to do this it's best if we run through an example. Now here's the example and I'll just read it to you. The battery has a lifetime which is normally distributed with a mean of 62 hours and a standard deviation of 3 hours. What is the probability of a battery lasting less than 68 hours? Well, the first thing we need to do is to define a random variable, which I'm going to call x. Let x be the random variable, lifetime in hours, where x follows a normal distribution with a mean of 62 and a variance of 9. We tend to write the mean as mu and the variance as the standard deviation, which is sigma squared. So if the standard deviation is 3, then 3 squared is 9. Okay, so the next thing I'd want to do is do a sketch of the normal distribution for x. So I need to label that axis x. We've got the mean here, which is 62, so that's the central value. We'll put that in. And we're looking for the probability of a battery lasting less than 68 hours. So I need to mark in the observed value of 68. So I'm going to mark it over here as 68. So I'm looking for the probability of being less than 68, which is represented by this area here. So just shade that in very quickly for you. Alright, so that's that area there. Now in order to do this, I need to standardize this particular normal distribution. By that I mean that we draw another sketch of a normal distribution underneath this one, label it z. Z represents the standardized normal variable, so that z follows a normal distribution with a mean of 0, which I'll mark in, and a standard deviation of 1. And if you square that, that means the variance is also going to be 1. Now what we need to do is look at the corresponding value of this observed value, which I'm going to call little x. Okay, there's not much room there, so I'll just say equals little x on that side. We need to look at the corresponding value of that 68. So if I project down onto the standardized curve and call this z, I need to work that z value out. Now there's a formula for this z value, which represents the number of standard deviations, by the way, that the observed value is above or below the mean. The z always equals the observed value x minus the mean mu, all divided by the standard deviation sigma. Always try and learn that formula. So if we apply it to this question, x is the 68, the observed value, minus the mean mu, which is 62, all divided by the standard deviation sigma, which in this example is 3. So put that in as 3. Work this out, and what do you got? You've got 2. Okay, and what that means is that the 68 is 2 standard deviations above the mean. And you can actually see that in this example very easily, because if the standard deviation is 3, then if I double that, that's going to be 6, and if I step 6 units above 62, it's going to take me to 68. So 68, as you can see, is 2 standard deviations above the mean. Z is 2. Now, working out the probability that x, which we'll write up here, the probability that x is less than 68 is exactly the same as working out the probability that z is less than 2. That is, the probability of being less than 2 standard deviations below the mean. That's this area here. And to work this out, we need to use tables. And you'll find sets of tables at the back of any textbook or in any book of tables. And those tables are what we call the cumulative normal distribution tables. And I've taken an extract here. You should find that these tables have got your z values and they've got this function here called phi z. Let me explain by way of this diagram up here. If you've got your standardized normal distribution, the probability of z being less than any value z is given by the shaded area is also equal to this notation phi z. So all I need to do is just simply look up z is equal to 2 on the tables, and it just so happens that z equals 2 is here at the very top, okay, and phi of 2 would be 0.9772. So I can write this in as being the same as phi of 2, and from tables you can see that that is 0.9772. And it's a good idea to always round these answers up to say 3 decimal places, because these particular tables are what we call 4-figure tables, and in reality there would be more digits for this probability behind that too. So to be sure of the probability we need to round it. So that's 0.977 to 3 decimal places. Okay, so that gives us the probability of x being less than 68. So hopefully you'll be able to model any question that is similar to this on this particular style. Well, that brings us to the end of this tutorial.